Okay, lesson 4-7. Okay, what's an inequality? What's an equality? Okay, when there's equal signs. So what's an inequality? What? Okay, with greater thans or with less thans, greater than or equal to, less than or equal to, correct. So we're going to be looking at some things in triangles that are not the same. There's a less than or a greater than type of relationship. Okay, we're going to explore first of all. Okay, with your ruler, draw an obtuse scalene triangle. Make it fairly good size. You need the sides to be straight, but yes, you probably should use a pencil with your ruler. Yes, pencil and ruler. That's what I think. We can make sure we're going to measure the sides and measure the angles. Yes, you can measure the angles. Okay, so once you've drawn your angle, make it fairly good size because you have to measure the sides and the angles. And if you're using your protractor, you know it has to be kind of big. Measure the sides, write the measurement on each side. Measure the angles also. Okay, then it says measure each angle of the triangle. Grab your protractor. Measure each angle of your triangle. No, she didn't. We can probably do what we're going to do with it. But, right. I think that's 141 degrees. Doesn't look like it's 90. Okay, what is something you could check about your angles? What should they total? 100. It should total 180. So you gotta be really close to that and maybe just change one of them like a degree or two. in order to get that. Okay. Now, do the sides have to add up to a certain amount? No, the sides do not, but the angles do. All the sides. All right, how many are done measuring everything? Hand up if you're done. Okay, we've got the majority of you. Okay, now what I want you to do is, oops, I don't want to show you that yet. Okay, you've got the side lengths. Okay, look at the longest side. If it's a right triangle, it's a hypotenuse, but you're supposed to make an obtuse triangle. Okay, so you see where the longest side is? Where's the biggest angle? Across from it. Okay. Where's the shortest side? Where's the smallest angle? Okay, what's the relationship between the shortest side and where the smallest angle is? Are they beside each other? Are they across from each other also? Shortest one's across from the smallest? Medium-sized one, is that across from the medium-sized angle?
Yeah.
Okay. That's what we're discovering in our lesson, or at least part of our lesson today. That in a triangle, the longest side is going to be across from the biggest angle. The shortest side is going to be across from the smallest angle. Now, how that is worded in our textbook is not exactly the words that I just said, but it's comparing two sides at a time. And they've got two theorems, one about the sides and one starting with the angles. So theorem 410, if one side of a triangle is longer than another side, so if one side's longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side.
So these theorems don't actually have sense.
Correct. They are triangle inequality theorems. So I suppose we could call that one the triangle side inequality theorem, and the triangle angle inequality theorem. The second one starts out with angles. If one angle is larger than the other, then the side opposite the larger angle is longer than the side opposite the smaller angle. We'll be using these theorems to put sides in order, like smallest to largest, or angles in order from biggest to smallest, or just say which one's bigger, which one's smaller. So I'm gonna draw some triangles on the board. I'm not gonna use a ruler, so looking at them, you won't be able to use my drawing to tell which is longest, which is shortest, things like that. So it might not be drawn exactly right. So let's draw something about like this. Let's say this side is 6, this is 8, this is 9. Okay, so I gave you the side lengths. So you would be using theorem 410. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. Okay, what I want you to do is, let's just have you first of all tell me which is the smallest angle. C. Angle C is the smallest. The measure of angle C is smaller than, what's the medium sized one? Angle A. So that makes the largest one angle B. Now if you're not with us, we're looking across the triangle. The shortest, or the smallest angle is across from the shortest side. So here's the shortest side, across the triangle, angle C. So angle C is not open very wide because it's making a short side. But the largest one, angle B, is across from the longest side, so that's open the widest because that side is longest. Now perhaps the question would just say, compare the measure of angle A to the measure of angle B. Should this be the measure of angle A is greater or less than? A is less than B? And I'm looking at the sides. Angle A is across from the side that's 8, B is across from the side that's 9, so yes, A is across from a smaller one, so it would be less than. So you'll have to read how the directions are asked. If it says put it in order, largest to smallest, smallest to largest, or if they're just picking a couple for you to do. All right, the next picture, it's going to look about the same probably. But let's put angles. Let's put an 80-degree angle, a 90-degree angle. That only leaves 10 over there, so let's put 70 and 20. Okay, so X, Y, Z. I gave you the angles. I want you to tell me the side lengths. And let's go largest or longest. Longest to shortest. Which side, why don't you grab your marker board? Which side is the longest? Next. So to find the longest side, let me put sides. I want the sides from longest to shortest. So what sides? Which one's the longest? The longest side is going to be across from the biggest angle. So pick out the biggest angle, the Y. Go across the triangle. So which one's the longest segment? And why don't we pick out the shortest one? Shortest side is across from the smallest angle. Smallest angle is 20. So across the triangle, XY is the shortest. And so in between would be YZ. You can't what? XZ is greater than YZ, which is greater than XY. Correct. All right, let's try another one. Here's a triangle. let's go with, let's go angles again. This one's 40 degrees, this one is 30 degrees, that doesn't add up well enough, I'll go bigger. Let's go with this one being 40, and this one being 50. And I know it doesn't look like it, but that ends up being a 90. Okay, let's go with M, P, N. Okay, should we go longest to shortest? We're go shortest to longest? Okay. Yeah, let's mix it up a little bit. Let's go sides, shortest to longest. The shortest side is going to be across from the smallest angle. One, put all of them down in order. First one, it's not right. Which angle's the smallest? The one what? I think your symbols are wrong. I meant smaller. Alright, the smallest angle was the 40 degree. So across from it, NP, or excuse me, NM, that's going to be the shortest side. Across from the smallest angle. That's smaller than, the medium-sized one was the 50 degree angle. So MP is the next in line, and the longest is going to be across from the 90, so that's NP. If I really made that look like a right triangle, the hypotenuse is always the longest. Okay, let's go back to this one. Let's stick with the side things for a little bit. On this one, I simply want you to fill in the blank, comparing side XZ to side YZ. Would you fill in the blank with a less than symbol or a greater than symbol? At 90 degrees in both of those. Is XZ longer or shorter than YZ? It should be a greater than. Which side is the XZ across from, or which angle is it across from? Okay, so I'm just going to make a note. That's across from the 90 degree. This side is across from the 70 degree. So the longer side is across from the bigger angle. So this one is going to be bigger than that one. You're not really comparing the angles, but that's what I'm using as a reference. Okay, let's stick with the same triangle. Let's have you compare YZ and YX. So you really wouldn't have that symbol on top. Okay, less than or greater than? So what angle it's across from to help you? Figured somebody would tell me if I shook my head no, it should, oh, I got my board upside down. So I changed the symbol. Alright, that one was greater than also. Okay, and on this one, let's stick with, let's go YZ compared to XZ. YZ compared to XZ. Sit across from. Okay, that one should be less than. The YZ is across from the longer side. Okay, let me change some numbers in here so I don't have a 90. Let's go with an 80, a 40, and a 60. I think that adds up to 180. Okay, I want you to compare side NM to side NP. What relationships? Okay, this one should be less than. NM is across from the 40-degree angle. NP is across from the 80-degree angle, so NM is going to be smaller. All right, let's try one more. Let's go with an obtuse look to it. And I'm going to give you sides. 20 inches, 10 inches, 17 inches. Okay, and the triangle is RST. Put the angles in order. Let's go largest to smallest. Tell me which angle is the largest. Use your angle symbols. Do you know which one's the longest or largest? The largest angle is going to be across from the longest side. Which side's the longest? This one. So this side's the longest. So I don't want those angles. I want the one across from it. Triangle S is the biggest. Medium-sized side is the 17. I don't want the angles on the ends of it, I want the angle across from it, R. So angle R is the next smaller, and the smallest is going to be across from the 10, the T. So that's the order they should have been. All right, seems like we're getting that idea. Let's go on. And we did some of those. Okay, let's try and form a triangle. Let's try the first one. Shade if I can find the right thing. Okay, just want to show me one of them. Okay, I want you to try and make a triangle out of what? Not on your marker board, no. Let's go on sheet of paper. Because I think we're going to use the compass as well. No. Alright, so have your ruler so that you can measure some exact lengths. We're going to try and make a triangle out of 4 inches, 2.5 inches, and 2 inches. I think the easiest way will be for you to start with 4 inches. Give yourself some room above and below it. And measure a 4-inch segment. So I'll call it AB. Now the other two sides need to be 2.5 inches and 2 inches. It's kind of hard just randomly drawing them because you don't really know, how high to go with your 2.5 inches in order to get it to connect. So the better thing to do is grab your compass and have your ruler handy. We're gonna set our compass at 2.5 inches. So I just put it on the ruler or right beside it. I'm putting the point at 0 and put the pencil at 2.5 inches. And I'm gonna go from the left hand in, and from A, I'm just gonna make an arc. Along there somewhere is gonna be a corner of our triangle, that's 2.5 inches away from the left hand. What's the other measurement need to be? 2 inches. So now set your compass at 2 inches. And from the right hand, point B, make an arc for 2 inches. Did your 2 arcs cross? Yes. And it probably doesn't look exactly like mine. Well, this is 4 inches. From here. 1 till 4.3 inches. You start at 1, you have to go to 5. So this first arc's probably going to be that second one. Okay, with your straight edge, draw your triangle. I'm just going to freehand it, but that made a triangle, right? We had 2 inches, 2.5 inches, and 4 inches. What kind of a triangle is it? Scalene, because all sides are different. How about by the angles? Acute, all those angles are less than 90. I don't think so. And that top one, got your protractor handy? How big's that top angle? It looks kind of fat to me, yeah? I think it is obtuse. So that was a scalene obtuse. All right, everybody got that triangle? Okay, let's try another one. 4 inches, 2 inches, and 1 inch. Got the idea how we did that? Okay, do that on a second combination. Start with the 4 inches. Then you want 2 inches and 1 inch as the other parts. What happens if what? Doesn't make a triangle? No. Why didn't that make a triangle? No, mine doesn't either. So how long was this to the arc? That was like 2 inches, right? And this one was 1 inch? And this was 4 inches?
Maybe it was like 3 inches.
If it were 3 inches and 1 inch would work? Why do you think that would work? 3 inches? Oh, you mean the bottom be 3 inches?
Yeah.
Okay. What if I changed instead of 2 inches, I made this 3 inches and 1 inch, would that work? That would work? Yeah, where would they meet? They touch right there.
It's a tiny triangle.
No, or is it a
It's still a
triangle?
triangle.
Is it a triangle? Or is it not?
No, it's not. Well, it's not a line.
What's 3 plus 1?
4. Oh, it's a line.
4, so in that case, it would be a line. Wouldn't be a triangle either.
Because it does not, it's like this much up, okay? It doesn't even.
Okay, so what does it need to be? This still wouldn't even work, right? It needs to be a tiny bit bigger?
It needs to be a 5.
Or what if
Okay.
the other one was 2?
Or 4.
or 2.
Or
So these two small ones, we have to make sure that they add up to be more than the bottom side. Otherwise, it's not going to make a triangle.
Yeah.
Right? Okay. So we could get different combinations, but what you're coming up with is to make a triangle, two sides have to add to be more than the other side. That's my plan all along. Yes. That is called the triangle inequality theorem. So did it make more sense for me to respond to it?
Probably.
That's the idea. Okay, so our triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Because if they're smaller, it didn't reach. It didn't make a triangle. If when you add the two sides, it's exactly equal to the other one, it's going to be flat. There's actually no triangle. It's just a line. Or a segment, I guess. Segment. So what would be some numbers I could put here? We could show what we just did. We did 4. We'll just make up some numbers. 3 and 2 and 4 would make a triangle because 3 plus 2 is greater than 4. 2 plus 4 is greater than 3. And 3 plus 4 is greater than 2. It works no matter which combination you look at. What did not work? Okay, we had a problem when we did 4, 2, and 1. That was really bad. And we even had a problem when it was 4, 3, and 1 because it was flat. Okay, so I'm going to give you 3 lengths and have you decide whether it would make a triangle or not. I think I'll just leave that up there. Okay, so your answer on, if you want some in your notes, then you just put your final answer on the marker board for me. Okay, will the lengths of 8, 8, and 6 make a triangle? Yes or no? And I guess I'm not going to trick you. Let's say it's all inches. Otherwise, if I didn't label it, I could say, no, it was 8 miles, 8 inches, and 2 centimeters. That's not mine. Cool. Can you draw me what you think that would look like?
Okay.
Doesn't have to be drawn exactly accurate, but what do you think it would look like? Where would the lengths be? Some are showing me a triangle that's isosceles 8 and 8, and then 6. I would say that's probably a fairly accurate idea. If it was obtuse, that last side maybe wouldn't be 6, it would be shorter, or it'd be longer, I mean. Okay, so just kind of a sketch of what it would look like. All right, let's do another combination. How about 10, 15, and 20? Will that make a triangle? Tell me what you think it looks like. Think it would be a right triangle? How would we know whether it really was a right triangle? We have to try that Pythagorean theorem. We have to see if 10 squared plus 15 squared is 20 squared. So it's hard to know whether it's acute or obtuse, or right. On tomorrow's lesson, we'll figure out whether it's acute, right, or obtuse. Okay, so this one was a yes, and some of you were giving me a good picture. Okay, let's try a 7, 7, 7. Does that make a triangle?
Yes.
Two sides always add to be more than the other? So what kind of a triangle is it? It should be equilateral when you draw out all three sides the same. And one more. Oh, we haven't had a no yet?
I think we need to have a no now first.
Well, would 6, 5, 11 make a no?
No.
No? No would not make a no?
It makes a yes.
Will it make a triangle?
No.
No. Okay. Does not make a triangle, it would be flat lines, right? Or segment. So what number here could I put for a more obvious no?
26.
If I put 26,
100.
that definitely is a no.
There we go.
Okay. 100 would be a no.
Even if you did 12.
What would be a yes?
4.
9.
Maybe a 4, maybe a 9.
That also makes right. 12. The 4 doesn't. No, it doesn't.
12?
12
No. The 6 and 5 doesn't have to be
So
more
like
than 12.
basically your range is 10 to
On what?
for
For
like
this?
no, not that. For the other number. The range.
Depends what the others are. Because if I put 200 and 5, this couldn't be 10. Right? Why? Because 10 and 5 don't add up to be more than 200.
Well, no, I'm just saying for that thing. So like it's showing it to be more than that.
So I could put something here as long as it was bigger than 1 in this problem. Bigger than 1 but smaller than 11. Would have been a yes. All right, thumbs up or down if you understand what you're doing on that. Does that make sense? Okay. We've got a little quiz today. Okay, the homework problems related to what we just did are page 214. Yeah, really mix you up. A few odds, a few evens.
Oh, Mary, don't mix up. I'm sorry.
Do we need construction tools for?
No. Your quiz is basically on Pythagorean theorem, Pythagorean triples, and distance formula.
Excuse me.
What was a Pythagorean triple?
What is that?
A, B equal C.
What?